Hey there, science fans. Have you ever felt the wind in your hair and marveled at its power? Wind is a natural force, and guess what? We can use it to make electricity. That's right, wind energy is a clean, renewable source of power. For centuries, people have harnessed wind power. We used it to sail ships and grind grain. Now we use giant wind turbines to capture the wind's energy. These turbines are like high-tech windmills, and they're popping up all over the world. Plus, it's a sustainable resource. The wind will keep blowing. So, are you ready to learn more about this amazing technology? Let's dive in and explore the fascinating world of wind energy. Before we talk about wind turbines, let's understand how wind energy works. Remember, energy can't be created or destroyed, only transformed. Wind turbines convert the kinetic energy of wind into mechanical energy and then into electricity. When wind blows, it pushes on the blades of a wind turbine. The blades are connected to a rotor, which spins like a giant fan. This spinning motion is mechanical energy. The rotor is connected to a generator inside the nacelle, the box on top of the tower. The generator converts the mechanical energy from the rotor into electrical energy. It uses magnets and coils of wire to create an electrical current. Voila! We've transformed wind energy into electricity. Now that we understand the basics, let's check out the different parts of a wind turbine. Blades. These are the giant arms of the turbine, usually three, designed to capture the wind's energy. Rotor. This includes the blades and the hub, which connects them. Nacelle. This box-like structure on top of the tower houses the generator, gearbox, and other important components. Tower. This tall, sturdy structure supports the nacelle and rotor, reaching high enough to catch stronger winds. These external components work together to harness the wind's energy. Inside the nacelle, the gearbox increases the rotational speed of the rotor shaft to match the generator's requirements. The generator then converts this mechanical energy into electrical energy. Section 4, internal mechanisms, the heart of the matter. Let's take a peek inside the nacelle and explore the internal mechanisms that make a wind turbine tick. Gearbox. This clever device sits between the rotor and the generator, increasing the rotational speed of the rotor shaft. Generator. As we learned earlier, the generator converts the mechanical energy from the rotor into electrical energy. Different types of generators can be used, but they all rely on the interaction of magnets and conductors. Controller. This is the brain of the operation. The controller monitors various factors like wind speed and direction and adjusts the turbine's operation for optimal performance. It can even stop the turbine if the wind is too strong or too weak. Section 5, wind to watts, the transformation process. Let's recap how wind transforms into electricity step by step. The wind blows and pushes on the turbine's blades, causing them to rotate. The blade's rotation turns the rotor, which is connected to a shaft inside the nacelle. The shaft spins the gearbox, which increases the rotational speed. The high-speed rotation of the gearbox shaft turns the generator. Inside the generator, magnets spin past coils of wire, creating an electrical current. The controller regulates the flow of electricity and ensures the turbine operates safely and efficiently. The electricity generated is then sent to the grid, powering homes and businesses. It's a fascinating process that harnesses the power of nature to generate clean electricity. Wind energy helps us combat climate change. It's a sustainable resource that will never run out. Section 6, wind energy in action. Applications and advantages. Wind energy has numerous real-world applications, and its advantages are plentiful. On-grid wind farms, large collections of wind turbines generate significant electricity fed directly into the electrical grid. Offshore wind farms, wind turbines erected in bodies of water take advantage of strong and consistent offshore winds. Community wind projects, smaller-scale wind energy projects owned and operated by communities to generate power locally. Residential wind turbines, homeowners can install small wind turbines to supplement their electricity needs. Wind is a sustainable resource that will never run out. Wind energy generation does not produce greenhouse gases or air pollutants. The cost of wind energy has decreased significantly, making it competitive with fossil fuels. The wind energy sector is a growing industry, creating jobs in manufacturing, installation, and maintenance. Section 7. Conclusion. Embracing a sustainable future. Wind energy is a powerful force for good, providing clean, renewable electricity that benefits people and the planet. By harnessing the wind's natural energy, we can reduce our reliance on fossil fuels and combat climate change. As we continue to develop and deploy wind energy technologies, we pave the way for a brighter and cleaner future. It's time to embrace the power of the wind and join the movement towards a sustainable energy future.